So this one is June 2018 paper. A compound of a D block element is dissolved in water to form a solution. The series of tests were carried out. Uh, First, the solution, it is a yellow brown. If we have like a green solution, it might be nickel, it might be chromium, might be iron too. But if it is a yellow brown solution is there, then it give an idea that it might be iron 3. And when solutions are there, how these compound, like it's not like free ion, it is existing. It is existing as a complex, so water ligands are attached to it. And the charge, when we write, it will be +3 here. So color, if it's yellow brown, it give an idea that iron 3. If it is green, it is iron 2 or nickel or chromium. Then sodium hydroxide is added. When we add sodium hydroxide, it is a test for positive ion. A brown precipitate are formed, which remain in. So what is the formula for the brown precipitate? Because it's iron 3. So first there will be acid-base reaction. 3 of the protons will be lost. And this will be the precipitate. Then we add 1 cm cube of a solution X in a test tube, added a potassium iodide. The color of a mixture in a test tube become dark brown. The dark brown color is due to formation. So what actually happened, like as a result, when iodine is added, like potassium iodide is added, so iodine or iodine will lose their electron and iron 3 will gain that electron. So iodine turn into potassium iodide contain iodines, it will turn into iodine molecule. That's why it become dark. The solution now, the color of a mixture in a test tube become dark brown. So why it become the dark brown color solution? Due to formation of what? Due to formation of iodine. Then 1 cm cube of solution X was added few drops of nitric acid followed by white precipitate solution X. So contain a chloride ion. So this is a test for halide. So how we usually test halide ion? We add silver nitrate, aqueous silver nitrate, and the solution X contain a chloride ion. So to test halide, chloride, bromide, or iodide, we add silver nitrate. 1 cm cube of a solution X was added sodium carbonate. Solution of X is acidic. So when we add sodium carbonate, so and it is an acidic solution, so what we'll observe? We'll observe fizz, bubbles, or effervescence. Sulfur dioxide is passed through a sample of X. A redox reaction happens which forms sulfur dioxide, in which the sulfur dioxide forms sulfate ion. The solution Y which formed is no longer yellow-brown. The series of a tests were carried out. So now sulfur dioxide turn into sulfate ion. So as a result, what will happen? This, because sulfur dioxide, whenever a sulfur dioxide is bubble, sulfur dioxide, the formula for sulfur dioxide is SO2 and it becomes SO4. So SO2 changes to SO4 ion. What is the change in oxidation number? Each oxygen is -2, so 2 oxygen will be -4. Sulfur will be +4. And here each oxygen -2, so -8 will be there for total, so sulfur will be +6. So if the sulfur +4 become +6, so in the solution we were having iron 3, because it's a redox reaction. If one substance is oxidized, the other must be reduced. So iron 3 will be reduced to iron 2. So sulfur dioxide is also used as a reducing agent. Capability, so the solution which was originally solution X was having iron 3, now it will turn into solution Y, which is now iron 2. This was iron 3. So now we are testing the solution of iron 2. 1 cm cube of a solution Y in a test tube added in excess of a aqueous ammonia. Whenever iron 2 is there, first a precipitate is seen, the color of the precipitate. So it will form a green PPT. Precipitate, the formula of the precipitate and the formula of cation in solution Y is. So As we add in a test tube, add an excess of a dilute aqueous ammonium. A precipitate is seen and the color of a precipitate is, as it is iron 2, so it will be dirty green precipitate will be there. So green or dirty green, you can mention. Then formula of the precipitate, it will be iron 2 hydroxide. And formula of the cation present, the positive ion which is present, so that is iron 2. Leave the mixture to stand for a few minutes, the surface of a precipitate turned brown. So actually what happened, like it was iron 2 hydroxide, it turned into iron 3 hydroxide. That's why the formula of the brown compound is, so iron 2 hydroxide turned into iron 3 hydroxide. Then complete the ionic equation for a reaction between the cation of solution X and the sulfur dioxide. So cation of solution X was iron 3 and it turned into iron 2. Now to balance the equation, to balance hydrogen, we add proton. So here 2 multiplied by 2, 4 are there. So we should add 4 proton. So this equation is balanced in terms of hydrogen as well. Then we have to balance the charge. The net charge is like the net charge should be balanced here. We have -2. Here we have +2. So net and then +4. So the net charge on this side is equals to +4. And net charge here is equals to +3. So the charge is not balanced. So we have to balance the charge. If I put 2 here, the charge will become 2 multiplied by 3, 6. Four protons are there. And sulfur dioxide, sulfate. This will be +4, -2, +2. And then if I put 2 here, so this will become 4. Sorry, yeah, 4 will be there. So 8 -2, that will become +6. So the charge will also be balanced. Before that, if there was one iron, the charge won't be balanced. That's why it should be 2 iron and 2 iron 3 and 2 iron 2. The next question is not organic analysis.